Hello everyone. In this video, we are going to discuss with the question largest rectangle in histogram. It's just the implication of monotonic stack. If you know the concepts of monotonic stack and you simply apply over here, the question is straightforward. So yeah, just go to the let's go to the question once. We are given an array of integer heights representing the histogram's bar height, where the width of each bar is 1. We need to return the area of the largest rectangle in the histogram. So what the question says is that we have some histograms of heights given and the width all of width 1. We need to say the area of the largest histogram. For example, in this example given to us, the largest rectangle possible is of height 5 and width 2. If we take this rectangle, then this is the largest rectangle possible. So for the given heights, we need to return the largest rectangle. The largest rectangle means the largest in the area. Okay. So let's see how we can solve this. Let's take this example only. We have 2, 1, 5, 6, 2, 3. 2, 1, 5, 6, 2, 3. These are the heights given to us. Just tell me one thing. If I say you that I am going to take a rectangle of height 2, if this is the part and like I am going to take this rectangle, this bar completely, the bar present at the first. If I am going to take this bar completely, then just tell me what are the bars which I can take from the right and from the left. अगर मैं ये बार ले रहा हूं तो if I take the bars from the right, the height of the bars to the right of this bar should be at least 2. Like अगर 2 से कम हुआ, for example this is 1, this is of height 1. So I can't take this bar, isn't it? And if I can't take this bar, I can't take any bar to the right of this bar. So my taking bars to the right ends over here. Similarly, to the left of 2, there is no bar. So I can't take any bar. So can I say that if I take this bar completely, then I can take only this bar of 2 size. Okay. Now if I say you that I am taking this bar of height 1 completely, I am taking this bar completely. Okay. So can you say that to the left, how many bars can I take? I can take the bars of heights at least 1 and continuous to the left of 1. For example, to the left of 1, we have 2. So we can take this bar 2. But which portion of 2 we will take? We will take this part, one portion. Like हम मान रहे हैं कि हम यहाँ height 1 हम लोग validate कर दिए. Okay. We fixed a height to 1. So just tell me the bars which I can take to the left of 1. I can take this 2. Similarly, to the right of 1, I can take 5, 6, 2, 3. I can take all these bars. But of what height? I will take their heights 1. Isn't it? Like ऐसा diagram है ना? ये 2 है, ये 1 है. This is 5. The other one is 6. The other one is again 2. And the other one is 3. So if I say you that I am going to take this bar completely, this bar of height 1, if this is the part, then I can take all the bars to the left and I can take all the bars to the right of height 1, isn't it? So हाँ ले सकते हैं. Now when I come to 5, if I say you that I am going to take this bar completely, this bar of height 5 completely. So just tell me the bars which I can take to the left and to the right. To the right, I can take the bars which have a height of at least 5 continuous to the right of this bar. So I have 6 which has a height of at least 5 and there are no other bars. Similarly to the left, I can take the bars which have height at least 5. So to the immediate left of 5, I have a bar of height 1 which has a height less than 5, so I can't take this bar. So can you feel that this question is reduced to something like, if I want to take a bar of a particular height completely, so till when I can take this height? Till when to the right I can take this height? Until and unless I get a bar which is smaller than the height of this particular bar, I can take this bar to the right, like I can take these bars completely. I can take this bar, but I can't take this one. Even after this one, if I have this, I can't take because I got a bar which is less than this particular height, isn't it? So I can't take this, any bar to the right of this bar. So just tell me to the how much we can get. Once I get a bar which have a height smaller than this particular bar, I can't take any bars from there. So can I say if I know the next smaller element to the right, I know that what is the position till when I can take the bar. This is one step. Now similarly, till when from till the left I can take the bar. Till the left, once I am not getting any bar of height which is less than this particular bar, I can take this. For example, I can take all these bars. But once I get a bar which has a height less than this particular bar, I can't take this bar if I consider this bar completely. So for this bar, if I know the next smaller element to left, so do I don't know that how many bars can I take to the left? Yeah, that's the problem in this case. So if we can find for every height, if we can find the next smaller element to left and next smaller element to right, if we find both of these things, so we are simply reduced to that. Okay, so if we take this height completely and we know the index of next smaller element to right and next smaller element to left, so we know the number of bars we can take, isn't it? So yeah, from there we can do our calculations. Like it's pretty easy. Let's dry run for this case and you will understand it. 215623. If I say you to write down the next smaller element to left index, like okay, so next smaller element to left, and let's say we have another vector which tells me next smaller element to right. If I talk of next smaller element to left, just tell me to the left of 2, what is the element which is smaller than 2? There is no element, so over here we will keep as -1. For 1, like this is index 0, this is 1, this is 2, this is 3, this is 4, and this is 5. Okay. When we come to 1, there is no element which is smaller than 1. Again, this keeps at -1. For 5, there is element at index 1, which is less than height 5. So over here, our answer will be 1. For 6, similarly, it will be 2. It is pretty much clear to what we discussed in our previous lectures. Next smaller element to left. So for 2, the next smaller element to left is at index 1. And for 3, the next smaller element to left is at index 4. Okay. Now, when we come to next smaller element to right, so we start from backwards for right. For 3, the next smaller element is no one. So which is at present as index 6. So can we say that next smaller element to 3 is at index 6? We are not keeping it as -1. We are keeping it as n. N is the size of this heights. Okay. You will get to know why we are keeping it as n, because we will simply get the difference pretty much easily. You will get to know once we calculate it. Okay. So for 2, the next smaller element to right is like no one. So again at index 6. Similarly for 6, the next smaller element is at index 4. For 5, the next smaller element is at index 4. For 1, the next smaller element is at index 6. And for 2, the next smaller element is at index 1. Now just let's do the calculation. We know that if we are going to take the element at index 0 completely, let's say this is the case, then just tell me how much area we can get. We are going to take this index of 0 completely, isn't it? So the height will be of what is at height index 0. So height is 2. Just tell me what is the width. Width is simply the number of bars we can take. How many bars to the left we are taking? It's nothing but 0 minus or minus 1. 1. 0, and how many elements to the right we are taking? 1 minus of 0, 1 plus 1 minus 1, because we took this particular element 2 times. So isn't it we are taking just one element? क्या कर रहे हैं देखो. We know that for this index, what is the next smaller element to the left? We know the index of that element. So if we subtract, we get this value. Similarly, for this index, we know the next smaller element to right, which is, let's suppose, this one. So if we subtract, we get this value. So what is the total number of bars? Total number of bars is nothing but this value plus this value minus this -1, because this is counted twice, isn't it? So yeah, this is the case. For example, this is index, let's suppose I. The next smaller element to index is L, and next smaller element to index is to the right is R. So what will be our answer? Our answer will be nothing but I minus L plus I minus R. But in this case, R minus I But in this case, we counted this bar at ith position twice. So we just subtract 1 from here. So this is the width. This is the width. That is why we kept -1 for next smaller element to left, and we kept 6 for next smaller element to right to get the appropriate answer. And once we multiply it with the height of the bar, we can get our answer. We can take the max of all the indices. So yeah, that's the approach we are going to follow. Let's code it down. It's very pretty much straightforward, the implications of next smaller element to left and right. So yeah, you can see that. Let's take the heights in the variable n. Okay, let's have a stack for next smaller element to left. Let's call it s1. And we have two stacks, let's suppose s1 and s2. And we have two vectors, next smaller element to left of size n and next smaller element to right of size n. Okay. Now what we can do, we can, for example, first of all, calculate for next smaller element to left. So for int I equals to 0, I less than n, I plus plus. What is the template? First of all, we do this thing like while not s1 dot empty and then heights of, like in the stack we are storing the indices, right? So yeah, we can how we can get the element at the topmost position, just we can do heights of st dot top to get the element of the topmost position of the stack. And while this element is, and what is the comparison with which we make? We make with this comparison heights of I, isn't it? So we want the next smaller element to write. So we need to delete all the elements which are greater than or equals to this particular element. So if the heights of st dot top is greater than equals to heights of I, this means that they are of no use to us, isn't it? So we will simply pop them out. So s1 dot, like s1 dot pop. Now after coming outwards of this loop, what we will do, we will check that if the stack is not empty, if the stack is empty, this simply means that there is no element to the left of this particular element which is smaller than this element. So in this case, what we will do, we will just say that NSL of I is equals to -1. And if other is the case, then we will say NSL of I is equals to nothing but st dot top. Because our stack is storing the s1 dot top, because our stack is storing the index, isn't it? And after all this stuff, what we always do, we push the current element we are at. So we will simply push uh, s1 dot push the indices, that is index I. Once we are done with this, we know that our NSL vector contains the next smaller element to left. Now this thing only we need for the next smaller element to right. So we can just simply copy it down. Like the complete code will be same. Let me show you how. You don't need to write it again and again. For practice, you can write it down. But if you're writing it like, if you have wrote it for many times, you can just simply copy it down. For next small element to write, what we do, we simply start from backward and nothing else. बस पीछे से शुरू करना है राइट के लिए. Okay, so this condition remains the same because we are finding the next smaller element only. Only these vectors will change and this stack will change. Okay, so once you are done with this, now we know that our next smaller element to right contains the next smaller element to the right of this particular element. So initially, let's keep our answer as int mean. Now let's traverse over the entire heights. What we can say, that answer is nothing but max of answer, comma, the present height, multiplied, what will be the width? The width will be nothing but I minus next smaller element to left of I plus next smaller element to right of I minus I. In this, we counted I twice, so we will just simply subtract -1. So after this, we will return our answer. Let's try to run it down one. We got a runtime error. Let's check why. Okay, we did over here s1.pop. It will be s2.pop. Okay, let's run it now. Okay, so in this case, if the stack is empty, okay. In the case of like the next small element to write, if the stack is empty, we will simply say that NSR of I is nothing but n, not -1, isn't it? That's what we did. That's what we discussed in our previous slides. Okay, it's working fine. Let's try to submit it down. Okay, it got accepted. So I hope you all understood the concept. Let's meet up with the next question in the next video. Thank you.